Hey there, awesome physics students. I wanted to do a force equilibrium example so you could see how these work. Now, in this case, we're using static equilibrium. So equilibrium itself just tells us that the acceleration is zero. Static equilibrium further says that the velocity is zero as well. The goal in this particular problem is that we want to find the values of the forces F2 and F1 applied to this beam here. Now, with forces, we have this beam. I've drawn the forces where they act, which is always the first step in one of these problems, is you want to draw a free body diagram with the forces where they act. However, if we're thinking about just the forces, we don't need to know any of the distances here in general because we're not thinking about torques. Okay, so how do we proceed? Well, as I said, the first step is to draw the free body diagram, which I've done. The next step then is to identify a coordinate system here, and I want to use the standard XY coordinate system because there's no compelling reason to do otherwise here. So the next step then is to sum the forces in the X direction and sum the forces in the Y direction. So let's start summing the forces in the X direction. So those would be side-to-side forces, so that's not in the X direction. This one, F2, is in the negative X direction. And then this one is not in the X direction. Part of this is in the X direction, to be this part here, and that's opposite of the angle 60. So, and that's going to be in the positive X direction. So that's going to be F1 sine of 60 degrees. And because the acceleration is 0, I set this equal to ma, but a is 0, so this is going to sum to 0. For the Y direction, now before I start going and summing forces willy-nilly, which you can do, let me just look at this one first. Notice that I have two unknowns, but I only have one equation so far. I can't solve that. I need another equation. So let's go ahead and sum the forces in the Y. So let's see, we have this force in the Y direction, the 50 Newton force, and that's down, so that's negative 50 Newtons. And then I have this not in the Y, this is in the Y direction, that's positive 25 Newtons. And then part of this is in the Y direction here, this F1, and that's going to be a positive F1 cosine of 60 because it's adjacent to that 60-degree angle. And that's going to sum to 0, again, because the acceleration is 0. Okay? All right, so with this equation, I have actually one equation, one unknown. I can go ahead and solve for F1. And F1 is going to be, if I combine these two, I get negative 25. And then I throw that on the other side, and that gives me F1 is equal to 25 newtons divided by cosine of 60. So I'm skipping a lot of the algebra steps here. I think I'll let you fill that part in on your own. When I compute this number, cosine of 60 is actually half, so this just is dividing by half or multiplying by 2, so this becomes 50 newtons here. So F1 is 50 newtons. All right, so then I can take my value for F1 and put it in up here. And now I have one equation and one unknown. The only unknown here is F2. So let me take this one down here, and I'll throw F2 on the other side. So this gives me F2 is equal to F1, which I know is 50 newtons now, times sine of 60 degrees. And so if I punch this in my calculator, this will give me the value for F2, and I've done that ahead of time. That's 43.3 newtons. So that tells me what F2 is. Okay, so now I know these forces, and notice that when I computed these, because I already included whether they were positive or negative in the equations here, the numbers here I'm going to get are generally going to be positive. If instead I found F1 is a negative number, what this means is that I guessed the direction of F1. Sorry, F1's over here. That means I guessed the direction of F1 the wrong direction, and it actually points the other way. And so if I get a negative in my answer, that's what that tells me. All right?